This graph shows you relationship between the number of days since you've been first exposed to some virus and the number of antibodies that are in your bloodstream. So there's two things that kick in. One is IgG and one is IgM, and if you want to learn more about that, that would be a biology course to take. But you can see on this, the IgM graph goes up, comes back down, and then goes up to the same level and comes back down, whereas the IgG graph goes up, comes down, and then goes up a lot higher. And a question may be, after first exposure, about how many days after first exposure does it take IgM, that's this graph, to reach its first local maximum, this highest spot right here. That's a local maximum on that graph. Well, it'd be about halfway between 0 and 14 days, maybe about 7 days. How long does it take IgG to reach its first local maximum? Well, that's about right here, and that's very close to 14 days. Again, we're just approximating, so maybe about 11 days. So it takes longer for this to kick in than it does this. So in terms of which helps you more when you first are exposed to some sort of virus, well, the IgM helps you more. But look at second exposure. When you're exposed again to some sort of virus, your IgM doesn't go up any higher level. But your IgG does, okay? So a lot more antibodies kick in. I think the M here stands for memory. So it's learned about this, and so it doesn't kick in as much, but the IgG kicks in a lot. And notice that the Y scale here for the number of antibody doesn't go up in equal units. One, like 1, 2, 3, 4, 5 or so. It goes 1, 10, 100, 1,000. So whereas your IgM after 42 days, or here, say around halfway between 28 and 42, maybe 35 days, it's only kicking in one extra antibody unit. Your IgG, after 42 days, is kicking in hundreds of extra antibody units coming in. So somewhere between 100 and 1,000. So this really has a much higher maximum than this does. If they didn't use this type of scale over here on the left-hand side, then we wouldn't see these little peaks, because if we were actually doing a regular scale, 1,000 would be extremely high, and we wouldn't see these little bumps right here. So these are called maximums on the graph. So let's go ahead and go on to the next. This graph shows the relationship between glomerular filtration and your BUN level. It also gives you another variable over here that is correlates to your blood urea nitrogen level, your BUN, and that's your serum creatinine level. Now, it gives you this little dotted line right here, and that is when you are having normal kidney function. And we can see that what happens is, as your glomerular filtration percent of normal drops below 100%, you're fine. Your BUN isn't too high. Like, for example, down here at 75%, if your kidney functions are functioning at 75%, your BUN level is still well below 25. Maybe it might be at 12.5. And your serum creatinine level would be somewhere between 2 and 0, maybe about 1 or so. But when your percent of normal drops down to 25%, and your kidney functions are only functioning at 25%, then you start to go through a rapid phase in which your BUN level, your blood urea nitrogen level, rapidly increase. So if this is a normal level right here, you want to stay below that level, then you're fine as long as your kidneys are working at least 25% fine. But as your, if your kidney function drops below 25% of normal, then your BUN level is going to go up very, very steeply. So what happens is this drops down and gets closer to 0. Your blood urea nitrogen level, your BUN level, and your serum creatinine level both go extremely high, and you're in bad shape. So for example, let's say we were down here somewhere, let's say 12.5%. Then you're right here, maybe at about 40 or so. But if you go down another half, let's say you're down to about 10, then you're in really bad shape. You're down, your blood urea nitrogen level would be really high. So it really doesn't matter that you understand what these things are about. What matters is that you're able to read these graphs, and these are a lot of real-life graphs that relate to the allied health areas that you'll see in those areas, and hopefully you'll be able to read those graphs. Like, for example, if somebody is at let's say a 10% of normal, that would be down here somewhere. What's their BUN level? Well, it'd be up high, about 75%, maybe even 100%. Sorry, that your BUN would be at 75 or 100. It's not in terms of percent. What would be your serum creatinine level? Well, that's on the right-hand side here. So when your BUN's at 75, your serum creatinine is about 7 or so. And when this is at 50, when your BUN's at 50, your serum creatinine level would be at about 4. So this is just showing you that there's two things that relate on the y-axis. That's pretty unusual. You'll see that the graphs that we actually are making on the next video are much easier than this, but it's very important to be able to know how to read a graph. So we'll stop there. One last graph, I forgot about this one. This one's a nice standard graph to read. Here it only has two variables. One is hours, and this one here is the serum concentration of a drug that you take. Let's say it's a Tylenol or whatever that you're taking. Then a question might be, how many hours after you take this Tylenol does it reach its maximum concentration? Well, that's what this is. It's concentration right here. And we could see that this maximum occurs right here. And how many hours is that? Well, that looks to be about 3.5 hours right here. Okay, maybe 3 hours. It depends if this number is supposed to be right underneath of that. But maybe 3.5 hours it reaches its maximum concentration. What is its maximum concentration? Well, here it says time to peak about 3 hours. So this is the third hash mark here. So 3 hours. And what is its maximum concentration? 80 units per milliliter would be its maximum concentration level. Now, after that, it starts to wear off and you get your headache back or whatever your pain is that you're suffering from. And here shows where you start to feel relief from this this headache or whatever due to this pain medicine kicking in. And you can see that you start to feel relief when you get a concentration of 15, and that occurs in about 2 hours, but it comes back down to that in about 6 hours. So this is the time in which you're getting some pain relief. This is the duration of action. It goes from 2 hours up to about 6 hours, or the duration of action is about 4 hours. And you can see after that it comes on down and leaves your system. So what a lot of people do is repeat a dosage to keep your pain relief up there high. So as it starts coming down, you take another dose, and it's going to keep that level coming back up there. So this is just reading points off of a graph. If somebody says, what is your level in 6 hours? Well, here you are. You just go up and go across, and it's about 15 units per milliliter. And 5 hours, what is it? Well, here's 5, and we would go up, hit the graph, go across, and you'd be about at 30. So we'll be making graphs on the next video.